Hello there, Mr. Sutton here, bringing you the IM3 Chapter 5 Quiz 2 review solutions on graphs of polynomials. To graph a polynomial, whether it's an intercept form like this or any other form, we need four things. We need to know where this thing is touching the x-axis, where, if possible, it's touching the y-axis. We also need to know what it's doing at the ends, the end behavior, and also what it's doing at each of those x-intercepts. So let's start by finding the x-intercepts. We can find that by basically setting this whole thing equal to 0 and solving. So whatever zeroes out each of these factors. So that's going to be -6 for that first factor. And that's actually a double root of -6. And then 3 for the other one. So let's put some dots on the x-axis at -6, which is somewhere back here, and +3 somewhere over on the right side. And this is totally not drawn to scale, but it is just a sketch. Now for the y-intercept, we basically have to plug 0 in for all the x values, because if x is 0, then you're on the y-axis. So we've essentially got 6 squared times -3, if I zero out those x's. And then this is 36 times -3, which is -108. And that's going to be somewhere down here. Next, for the end behavior, we have to see what the degree of this thing is, which is to say when you multiply all the x's together, what's your exponent? We also need to know if it's a positive or negative first term. So basically, just ignoring these constants that go with the x's, we basically have an x squared times an x. That's going to give us our lead term. And that's going to be an x cubed. Now, in general, this is going to be a positive x to an odd power. So if you have a positive x to an odd power, this is going to behave basically like a line with an upward slope in terms of its end behavior. So kind of like the graph of y equals x, kind of like this line right here. This means we're going to be starting below the x-axis and ending above it. Now, just to go over a few hypotheticals, if this had been a negative x to an odd, then you would have had a sloping down line, so starting above, ending below. If this had been a positive x to an even power, this would have looked like an upward opening parabola, starting and ending above. And if this had been a negative x to an even, you would have started below and ended below like a downward going parabola. But this was our situation, so we're starting down here and ending up here. Now, we also need to figure out what we're doing at each root. Now remember, there's 3 things that can happen at your x-intercepts. You could cross straight through, you could bounce, or you could go through but in a flattening fashion. And that's going to depend on the multiplicity, basically the number of roots of that type you have. For example, at 6, this is a, rather -6 I should say, this is a double root because it came from a squared parentheses here. So double roots are going to bounce, and single roots, like the 3 that comes from this x minus 3, are going to just cross straight through. Now, if you had a triple root, something that had the third power here, then you would be flattening. So putting it all together, we're going to start below the x-axis, and we are going to bounce at -6, go through our y-intercept here, and now we're going to cross at 3. And you'll notice that we end up above the x-axis, which is where our end behavior said we should end up. Notice that if you start in the correct place and make the correct choice at each of your x-intercepts, you should end up in the right place. And then this end behavior over here is really just kind of double-checking that you are in the right ballpark. To graph a polynomial that is in standard form, like this one, we're going to still need all the information we needed in intercept form. So roots, y-intercepts. We also need end behavior and root behavior. The difference is that we have to do slightly different things with this form to get that information. For example, for roots, we can't get the roots in this format. We need things factored out. We need intercept form to easily find the roots. So our very first step is actually going to be to factor this so that we can get the roots. So taking a look at this specific situation, I always look for common factors before anything else. And I notice these all have at least an x squared. So I'm going to take out an x squared. In fact, since there's a negative for this lead term, I'm going to take out a negative x squared just so that first lead term is positive. So factoring out a negative x squared, this negative x to the 4th becomes positive x squared. And then this 7x cubed, now I've got a negative 7x. And finally, negative 12x squared becomes positive 12. I can factor the stuff inside a little bit more. I need factors of 12 that add up to negative 7. 1 and 12 won't do it, neither does 2 and 6. 3 and 4 works, though, if you have negative 3 and negative 4. So I've got a negative x squared still. I've got an x minus 3 and an x minus 4. Now that I've got intercept form, I can just zero out each of these factors to get my roots. So for this x squared, we see that we have a root of 0. And then for this middle factor, we have x equals 3, and then 4 for this last factor. Putting those on this graph here, we've got 0 at the origin, 3 is somewhere to the right of that, and 4 is somewhere further to the right. So now we know what our graph is going through in terms of the x-axis. It can't go through the x-axis anywhere else. In terms of y-intercepts, you might notice that we have the origin here, which is both an x and a y-intercept. It's on both axes. But you can always double-check x-intercepts. With standard form, you're always looking to see what the constant is at the very end. Now here we have an invisible 0 for a constant, but whatever the constant is, that's going to be your y-intercept in standard form. And you can think about it as if you zero out all the stuff with x's in it, you're just going to be left with that constant at the very end. So our y-intercept is 0, but we already kind of knew that by looking at the graph. Now for the end behavior, we always have to look at the exponent and the sign of the lead term for that. But the lead term is already given to us in standard form. In this case, it's this negative x to the 4th. So that's a negative x to an even power in this case. And we know that this is then going to behave like basically a negative x squared, like an upside down parabola, which means we are going to start below the x-axis and end below the x-axis. And now for the root behavior, taking a look at what we're doing at each of these intercepts here, 0 is a double root because it came from this x squared, so we're bouncing at 0. And then 3 and 4 both came from single power factors, so we're going to cross straight through those. So starting below the x-axis, we bounce at 0, come down here, come back up and cross through 3, then we come down and cross through 4, and we end below the x-axis, which is where our end behavior said we should end up. For this problem, to find a possible equation for a polynomial graph, let's start by figuring out whether the whole thing should be negative or positive. We can do that by looking at the right side end behavior. If the right side end behavior is ending above the x-axis, going up, then the whole function is going to be positive. If this right side end behavior were going down, then we could conclude that we had a negative function. Since we're ending up here, that means we have a positive function. So I'm going to write y equals, and then you can think of there as being kind of an invisible plus sign right here. I don't have to write it, but it's there. Now I also need the factors that I'm going to do for this. It's going to be in intercept form. So I have to look both at where we are crossing and the manner in which we are touching the x-axis, whether we're crossing straight through, bouncing, or flattening. So it's always going to be x minus whatever the root is. So for this first one, we would have x minus negative 9, or just x plus 9. And the exponent that goes on this factor, again, is going to correspond with whether you're crossing, bouncing, or flattening. If you're just crossing straight through, then you've got the first power, that's just a single root, and you don't have to write a little 1 up here, although you could if you wanted to. Now for this next one, we're bouncing at negative 7. So this is going to be x plus 7, all of that to the second power. And then for this last one, we're flattening through 2. So this is going to be x minus 2 raised to the third power, because we have triple roots giving us flattening. And this is a possible equation. To write a specific equation of a polynomial where a point is given, such as this problem where they gave us the point negative 1 comma 4, they told us that point, which is right about here, is on the graph for sure. We're basically going to start by finding a possible equation, only we're going to put a little a out in front of everything just to represent kind of an unknown constant that we're going to have to find to make things really specific. So we also want to figure out in the beginning, should this function be positive or negative? So taking a look at this one, since we're ending above the x-axis, since we're going up as we move to the right, this should be a positive function when all is said and done. So I'm going to write y equals positive a just to kind of start things off. And after that, I'm going to put in all the factors here that we need. Now, if this had been going down as we move to the right, then I would have written y equals negative a. But since it was ending up, we have a positive a here. All right, so for our factors, it looks like we are crossing it, or bouncing at least, at negative 2. So that's going to give me a factor of x plus 2, which is really x minus negative 2. And I'm going to have to square that because we're bouncing. So it behaves like basically behaving like an x squared at that one spot. So x plus 2 squared. And then let's see here. We come back down and cross, it looks like, through x equals 1. And that's just crossing straight through, so that's a single root. So I'm going to write x minus 1, and then basically an invisible first power there. And we're also crossing through x equals 3, so we have an x minus 3 to go at the end. At this point, we still need to find what this a value actually is. So to do that, we're going to plug in the point that they gave us, negative 1 comma 4. So 4 is going in for the y right here. And I'm going to substitute negative 1 for all these x's. So I've got a times, and now I'm going to have negative 1 plus 2 squared, negative 1 minus 1, and negative 1 minus 3. Cleaning things up a little bit on the right side, negative 1 plus 2 is just 1. Squaring that, still 1. So that's just 1a, so that doesn't really change a whole lot. Next we have a negative 2 and a negative 4. Multiplying those gives me a positive 8, so I end up with 8a on the right side. Dividing by 8 to get my a value, I've got 4 over 8, which is really 1/2 if you reduce that. And then as our last step, don't forget to actually plug your a value back into what you wrote in the beginning. So this is going to be y equals 1/2 x plus 2 squared, x minus 1, x minus 3. And that is a specific complete equation.